All right, let's get right into it. You know, when you picture the ocean, you probably think of this huge, uniform body of water. But the truth is, it's alive with these incredibly powerful currents that literally shape our world. Today, we're going to focus on one of the most important of all, the Gulf Stream. It's basically a giant heat pump for an entire continent, and it might be in serious trouble.
It really does sound like something out of a sci-fi movie, but it's absolutely real. Hidden inside the Atlantic Ocean is a massive, warm river that completely controls the climate for millions and millions of people. I mean, it's the reason Paris has much milder winters than, say, Montreal, even though they're at similar latitudes. This one current is a cornerstone of our global climate.
And that is the big, scary question we're looking at today. The thought of this massive force just grinding to a halt is, well, it's pretty alarming. And it's a possibility that climate scientists are taking very, very seriously. To really get why, we first have to understand how this whole incredible system even works. So before we can talk about the Gulf Stream specifically, we've got to zoom out and look at the bigger picture. See, the Gulf Stream is just one piece of a much larger, planet-spanning system. The best way to think of it is like a global conveyor belt, always moving water and with it, heat, all around the globe. It's like our planet's thermostat. Now, the official scientific name for this conveyor belt is thermohaline circulation. Sounds complicated, I know, but the name actually tells you everything you need to know. Thermo means temperature and haline means salt. So really, it's those two things, temperature and saltiness, that act as the engine driving this entire global system. And here's the key. It all boils down to density. It's basic physics, really. Warm water is less dense, so it rises up. Cold water is denser, so it sinks down. And the exact same thing happens with salt. Water that's really salty is heavier, and it sinks. Water that's less salty, or fresher, stays near the surface. Now take that simple idea and scale it up to the size of an ocean, and you get this colossal, non-stop circulation of water. Okay, so keeping that big global conveyor belt in mind, let's zoom right back in on the star of our show today, the Gulf Stream. It's hands down the most famous part of this whole system, kicking off in the warm waters down near the equator and then heading northeast right across the Atlantic. And the numbers here are they're staggering. We're talking about a 10,000-kilometer-long river, moving along at about 2 meters a second. But just look at that flow rate, up to 100 million cubic meters of water every single second. That is more water than all of the world's rivers on land combined. And it all begins in the Gulf of Mexico, where the water gets heated up to a really warm 30 degrees Celsius. Now, this isn't just some interesting fact for a science class. It has a massive direct impact on Europe's climate. All of that warm water traveling north carries an unbelievable amount of heat with it. And as it moves, that heat gets released into the atmosphere, which in turn warms up the entire continent. So just how much of a difference does it make? Well, on average, Western Europe is a full 5 to 10 degrees Celsius warmer than it would be without the Gulf Stream. That is the difference between having green fields and having an icy landscape. And if you want to put that energy into perspective, get this. The amount of heat the Gulf Stream delivers to the coasts of Europe is the same as the energy output of 1 million nuclear power plants. It's a natural engine with almost unimaginable power. So yeah, the stakes are pretty clear. The European landscape that we all know, it's a direct result of this warm ocean current. Without it, the continent would be a much, much colder and harsher place to live. So what is it that keeps this massive river in the ocean flowing? It's not just the wind. The real engine of the Gulf Stream is actually thousands of kilometers away from where it starts, up in the freezing cold waters of the North Atlantic. Here's how it works. As that warm Gulf Stream water travels north, it starts to cool down, releasing all its heat. At the same time, some of the water evaporates, but it leaves the salt behind, so the water that's left gets even saltier. This combination of being cold and super salty makes the water incredibly dense and heavy. So heavy, in fact, that it sinks, plunging thousands of meters right to the bottom of the ocean. And it's that sinking motion that actually pulls more warm water up from the south to replace it, keeping the whole current moving. And the places where this sinking happens are just incredible. Scientists have a great name for them: chimneys. And what they are, essentially, are the world's largest waterfalls. They just happen to be completely underwater. Just try to picture these enormous columns of water just dropping off a cliff into the deep ocean. The statistics for these chimneys are absolutely mind-blowing. We're talking about waterfalls that are 15 kilometers wide, plunging 4,000 meters deep. The flow rate of just one of them is 17 million cubic meters per second. That's 15 times more water than all the rivers on land all over the world combined. This colossal sinking action is the engine that drives the entire Gulf Stream. Okay, so if this powerful engine has been running like clockwork for thousands of years, what's the big deal? Well, the threat is coming from the north. It's coming from the massive amounts of ice that are melting because of climate change. You can think of it like someone throwing a wrench into the gears of this perfectly tuned machine.
As our planet gets warmer, the gigantic ice sheet that covers Greenland is melting faster and faster. And this isn't salty sea ice we're talking about. This is ancient, frozen, fresh water. And it's now pouring into the North Atlantic in enormous quantities. Remember how the engine works? It all depends on that surface water becoming very cold and very salty so it gets dense enough to sink. But this huge flood of fresh water is diluting the ocean's surface. It's making the water less salty, and because of that, less dense, less heavy. And that brings us to the ultimate danger. If the water isn't heavy enough, it won't sink. Those underwater waterfalls, the chimneys, could get weaker and weaker, or even stop completely. And if that happens, the engine that pulls the Gulf Stream north just shuts down. The heat pump for an entire continent could be turned off. So, is this a sure thing? Is Europe about to be plunged into a new ice age? Well, the future is really complex, and right now, the scientific community is having a serious debate about what could happen next.
We know just from looking at Earth's history that this system isn't invincible. The geological record is pretty clear that during the last ice age, a massive release of fresh water from melting glaciers did, in fact, shut this current down, and it threw the northern hemisphere into a deep freeze. After thousands of years of stability, we are now in a period of incredibly rapid change, and that makes the future very, very uncertain.
So, scientists have different views on this. You have some who argue that the rate of ice melt is a critical threat that could trigger a shutdown very soon, and they point to those past events as proof that this can happen really abruptly. Then you have others who believe the global climate system is much more complex and maybe more resilient, and that other factors could step in and compensate for all this fresh water. But the one thing they all agree on is that we are pushing a stable system into a completely unknown state. And that really leaves us with the final, crucial question. The Gulf Stream is just one piece of this incredibly intricate climate machine that has kept things stable for thousands of years. By changing such a fundamental part of it, we're basically running a massive experiment with the only planet we have. So what happens when a gear this important starts to break?